Another learning day, everyone. This is your teacher Marlene, and we have to start another chapter in Mathematics 9, which is all about the similarity of triangles. And prerequisite topic is the idea of proportionality. So we have to recall the topics of ratio and proportion. And let us see its application in solving problems. Our topic is indicated in the most essential learning competency, number 34, which is to describe a proportion, and number 35, to apply the fundamental theorems of proportionality to solve problems involving proportions. So, I hope at the end of my discussions, all of these competencies are clear and can put into practice. So let us start.
The idea of proportion is started with the ratio. So let us recall the ideas about ratio. It is defined as the comparison of two quantities of the same kind and in the same unit by division. So remember, we are comparing two quantities in a ratio. In symbols, it can be written in two ways: the ratio form itself or the fraction form. In both ways, the ratio is read as A to B. Now let us look at this example. The given are x is equal to 6, y equals 18, and z equals 15. Find the ratio in simplest form. So the first task is x to y. By substitution of values such as x is equal to 6 and y is equal to 18. Now since 6 and 18 are both divisible by 6, so our LCM is 6. And dividing both the numerator and denominator by 6, the simplest form is 1/3. So the ratio of x to y is 1 to 3. Now how about y to z? Again, let us substitute the value y is equal to 18 and z is equal to 15. The LCM of 18 and 15 is 3. So the simplest form is 6/5. So the ratio of y to z is 6:5. Now let us see if x plus z is to y. Substitute x equals 6, z is equal to 15, and y is equal to 18. Then simplify. 6 plus 15 is 21. So we have 21 is to 18. Now the LCM is 3. Then the simplest form now is 7 to 6. Now have you recalled everything about ratio? If you have further questions, just put it in the comment box below. If everything about ratio is clear, we can now proceed to proportion, which best describes as the equality between the two ratios. Meaning, if you encounter two equal ratios, they are called proportion. Let us consider this. A to B is equal to C to D. We can check the proportionality of the given if we look at the product of extremes, which are the outer parts represented by A and B, which must be equal to the product of the means, which are represented by B and C. So in proportion, the product of the extremes equals the product of the means. Or, if the proportion is in fraction form, we can do the cross multiplication. Now, let us look at the following examples. For example number 1, let us look at the figure. So, on the left, there are 2 yellow triangles and 3 green triangles. But, if we are asked to write the ratio of the yellow to the total number of triangles, the ratio is 2 to 5. On the other hand, the ratio of the right side group of triangles is equal to 4 yellow triangles to 10 total number of triangles. So if we want to check for the proportionality, we have 2 times 10, which are the extremes. Is it equal to 5 times 4, which are the means? So 2 times 10 is 20, while 5 times 4 is also 20. Since 20 is equal to 20, then we can conclude that the figure is a kind of proportion. Now let us have example number 2. Find the value of x in the proportion 4 to x is equal to 2 to 6. Let us get the proportion. So since the given is in the form of fraction, let us do the cross multiplication. So the 2 times x is 2x and 4 times 6 is 24. Then dividing both sides by 2, the value of x is 12. Now let us do the checking. There are 2 ways to check if our obtained value of x is correct. So first, let us substitute the obtained value in the proportion. So 4 to 12 is equal to 2 to 6. Then simplify by dividing both sides by the LCM. So between 4 and 12, the LCM is 4. And between 2 and 6, the LCM is 2. So the result is 1/3 is equal to 1/3. On the other hand, if we apply the cross multiplication in the proportion, such as 2 times 12, is that equal to 4 times 6? And we have 2 times 12 is 24, and the same with 4 times 6. So in both ways of checking, the left and the right values are equal. Therefore, x is equal to 12 is the correct value for x. Now, for example number 3, find the value of x in the proportion x plus 1 is to x plus 2 is equal to 2 to 3. So to find the value of x, we will use the cross multiplication. We will get 3 times the quantity of x plus 1 is equal to 2 times the quantity of x plus 2. Then apply the distributive property. 3 times x is 3x plus 3 times 1 is 3. This is equal to 2 times x is 2x plus 2 times 2, which is 4. Then applying addition property of equality to combine like terms. So we will get 3x minus 2x is equal to 4 minus 3, where 3x minus 2x is equal to x, and 4 minus 3 is equal to 1. So we can check this mentally by substituting 1 for x in the given proportion. So 1 plus 1 is 2, and 1 plus 2 is 3. So 2 is to 3 is equal to the right side ratio, which is also 2 to 3. So the value of x is equal to 1 is correct.
Now observe our example number 4. We have to find the value of A, B, and C in the proportion A is to 24 is equal to B is to 8 is equal to 6 is to 16 is equal to 18 is to C. Now to solve for the missing value, you have to look for a complete ratio, which is 6 is to 16. Now this ratio will help us to find the missing variable. Now to find for A, let us choose the proportion A is to 24 is equal to 6 is to 16. So similarly, to find B, we will use the proportion B is to 8 is equal to 6 is to 16. And to find C, the proportion 6 is to 16 is equal to 18 is to C. Now let us solve for A. By cross multiplication, A times 16 is 16A, then 24 times 6 is 144. Divide both sides by 16, so the value of A is 9. Same process to find B. Let us apply the cross multiplication. So B times 16 is 16B, and 6 times 8 is 48. Now divide both sides by 16, so the value of B is 3. Then finally, let us solve for C using the same process. 6 times C is 6C. Then 16 times 18 is 288. And divide both sides by 6, so the value of C is 48. Now, if we substitute A, B, and C in the given proportion, such as 9 to 24 is equal to 3/8 is equal to 18 is to 48 is it equal to 6 is to 16. So if we're going to simplify all of this, the value is simplified into 3/8. So obviously, the values of A, B, and C are correct. Now let us see how will you apply the process of solving ratio and proportion in the following problems. Let us see example number 5. Two supplementary angles are in the ratio 7 to 8. Find the measure of each angle. So let us represent x as the measure of one part of the angle. So in the problem, the ratio is 7 to 8. Now since the two angles are supplementary, as stated in the problem, then the equation is 7x plus 8x is equal to 180. Now combining 7x and 8x, that is 15x. And dividing both sides by 15, the value of x is 12. Now before we conclude that our answer is correct, let us do the checking. Now substituting 12 in terms of x, we will get 7 times 12 plus 8 times 12. Is that equal to 180? So 7 times 12 is 84, while 8 times 12 is 96. Then combine 84 and 96, the result is 180. Now we can say that the measure of the two angles are 84 degrees and 96 degrees. Now let us see another application in our example number 6. A 144 centimeters line segment is to be divided into two parts with a ratio 3 to 5. Find the length of each segment. So we have to represent x as the length of one part of the segment. So we will consider the ratio 3 to 5. So the equation is 3x plus 5x is equal to 144. Now combining 3x and 5x, that is 8x. Then divide both sides by 8, so the value of x is 18. Let us do the checking. By substituting 18 in terms of x, so we will get 3 times 18 plus 5 times 18 is equal to 144. So 3 times 18 is 54 and 5 times 18 is 90. Then add 54 and 90 will give us 144. Therefore, the length of the segments are 54 centimeters and 90 centimeters. How about this problem in example number 7? Two line segments are in the ratio 5 to 7. If one segment is 12 centimeters shorter than the other, how long is each segment? Now, since in the problem is stated that one segment is 12 centimeters shorter than the other, so we have to represent x as the length of the longer segment, and x minus 12 be the length of shorter segment. Now, the given ratio is 5 to 7. Then we can create our equation using proportion between the shorter to longer segments. So, x minus 12 is to x is that equal to 5 to 7. Then using extremes and means, let us multiply the extremes. X minus 12 times 7. So it is 7 times x minus 12. And the product, we have the means 5 times x. By distributive property, 7 times x is 7x. And 7 times negative 12 is negative 84. And 5 times x in the right side is 5x. Now, applying addition property of equality, so that we will have 7x minus 5x is equal to 84. Then combine 7x minus 5x, that will give us 2x, that is equal to 84. Then divide both sides by 2, so that the value of x is 42. Now let us check by substituting 42 in terms of x. So 42 minus 12 is to 42 is equal to 5 to 7, where 42 minus 12 when simplified is 30. Then between 30 and 42, the LCM is 6. Dividing them by 6 will simplify to 5 to 7. Now, since the left and right ratios are equal, we call this as proportion. Therefore, the segments are 30 centimeters and 42 centimeters long. Well, I hope you learn in my discussions. For further questions or clarifications, just put your comment. And to keep the learning goals, watch my video lessons in my YouTube channel, Teacher Marlene Nuno. Subscribe mo na rin and hit the notification bell para updated ka sa mga lessons ko. You can also be part of the community channel if you can comment your answer and how well do you know. So para may chance ka rin sa mga raffle ko. Now try to answer this. Is this a proportion or not? Can you justify your answer? Or konting paliwanag? So rate ko mga sagot nyo. Laging tandaan, maganda ang kinabukasan ng mga taong may pinag-aralan. Keep on learning! God bless everyone!